All right, today we are going to take a look at nonlinear inequalities. One of the few reminders that I'm going to give you here at the beginning is back when we were learning things like domain and range, we talked about when we use parentheses versus brackets. So just a reminder that if we have a less than or a greater than, that we use parentheses to indicate that we do not include that number. And if we have an or equal to, that we're going to use a bracket to indicate that we do include that number. The other thing is just remember what kind of number we're looking at. In all of our problems today, we're looking at inequalities. If we have a number that is less than 0 or less than or equal to 0, we are specifically talking negative numbers. If our number is greater than or equal to or greater than 0, we are specifically talking positive numbers. Okay, today we're going to utilize what's called a sign chart. So here are your sign chart basics. One of the things you'll do is you will find the zeros of the function. So remember, factor, set anything equal to 0 that has an x. So x equals 0, x plus 2 equals 0, x minus 1 equals 0. And you put each of those zeros along a number line that starts at negative infinity and goes up to infinity in numerical order. So we have 0, negative 2, and 1 all on our sign chart. And then all I'm going to do is go test out sample numbers. So if I were to test a sample, so these are all my zeros. That's a 0, that's a 0, that's a 0. If I test a sample number in an area, I could test something less than negative 2, like negative 10. And all I'm going to do is I'm going to go plug negative 10 into each of the different factors above. And I don't need to know what number it is specifically. I just need to know if that number is negative or positive. So we've got 3 spots up there, x plus 2, x minus 1. As I plug negative 10 into that first spot, I would end up with a negative number. When I plug negative 10 into x plus 2, I end up with another negative number. And when I plug negative 10 into x minus 1, I end up with a negative number. So 3 negative numbers. And if I multiply 3 negative numbers together, first of all, as I multiply 2 negative numbers together, I get a positive. Times 1 more negative, I would get a negative number, which means all of my answers in that interval from negative infinity up to negative 2 would all be negative. And we do the same thing. As I just continue to pick sample numbers in each section, so something between negative 2 and 0, a sample number would be like negative 1. And I plug them into each of the spots above. So if I plug negative 1 into that first spot, it'd be a negative number. Negative 1 plus 2 is a positive number. Negative 1 minus 1 would be a negative number. And when I take a negative number times a positive times another negative, overall it would turn out positive. Next one, a little tricky. I'd have to pick something between 0 and 1, like a half, 0.5. Okay. Plug a half into that first spot, I get a positive number. A half plus 2 is positive. 1/2 minus 1 would be a negative number. Multiply all of those together, overall I would get a negative. And then something bigger than 1 would be like positive 10. And it doesn't matter what, but you can pick anything bigger than 1. Plug it into that first spot is positive, second spot is positive, 10 minus 1 is positive, positive times a positive times a positive is positive. So what are we looking at here, and how does that correspond to if we were to graph that actual polynomial? Well, it would have had zeros at negative 2, at 0, and at positive 1. In the sections where it said negative, that would be below the x-axis. So from negative infinity up to negative 2, that graph would have been below my x-axis. From 2 to 0, it says positive, which is above my x-axis. From 0 to 1, it's negative, which is below my x-axis. And then from 1 to infinity, it says positive, which is again above my x-axis. So you can see that it's the shape of an x cubed graph, which is what we would have had, and crossing through at each of those zeros. So kind of getting that corresponding to the negative, the positive, the negative, the positive, and what that means visually for our graph. So that's how we're going to solve these. And we'll talk about what we're missing is the very last step in how we solve this. Is then reading the inequality sign at the end and picking the correct intervals to answer that inequality. Okay, so the first thing you'll see on this one is off to the side it lists the steps. Set it equal to 0, solve for x, that's finding our zeros, make our sign chart. That is what we just saw all happening on the last page. What we're adding to this then is the last step that says write your answer in interval notation. And the answer is going to come from this question over here. What does this sign tell you, or what type of numbers are we looking at? So we'll look at that sign when we get to that last step, writing our answer. So this one, the first couple steps are pretty much done for us. Set it equal to 0, solve for x. We have zeros of 5 and 3, and I make my sign chart. So my sign chart, again, is going to go from negative infinity up to infinity, and we'll put all those zeros on here. So of positive 3 and positive 5, put them in numerical order. Those are my zeros. And then we just test some numbers in each section, plugging them into that inequality above to see if it comes out positive or negative. So something less than 3 would be like 0. If I plug 0 into x minus 5, I get a negative number. 0 minus 3 is a negative number, and a negative number times a negative number is a positive number. Pick something between 3 and 5 like 4. 4 minus 5 is negative. 4 minus 3 is positive. So a negative times a positive is a negative number. Something bigger than 5 would be like 10. 10 minus 5 is positive. 10 minus 3 is positive. And a positive times a positive is a positive. So that's what we did on the last page too. And now the last part of it is reading our answer. And that comes from this part of the inequality. What is that asking us to find? We want numbers that are less than or equal to 0. So we want the sections that are negative. And because of the or equal to, we are going to include the zeros or use brackets. So negative sections in this graph would be this interval right here from 3 to 5. And it says we are including the zeros. So it's a 0 at 3, so I use a bracket up to 5. That would be the part that would make this inequality true. Okay, and so we're going to just follow those steps for all of these. This one we have a little bit more work at the beginning, and this is what we have to be cautious of. Not equal to 0 to start with. First thing I'm going to have to do is get it equal to 0 before I start finding the zeros of the function. So we'll start out by subtracting 46 from both sides. Okay, finding my factors of negative 36 that add up to negative 9 would be, let's see, negative 12 and positive 3. Setting those equal to 0 and solving, I get a 0 at x equals 12 and a 0 at x equals negative 3. Okay, next we're going to go to our sign chart here. So I put those zeros on there, negative 3, positive 12. And again, we're just going to start picking our sample numbers. So something smaller than negative 3 would be like negative 10. And I'm going to go plug those back in. Above, negative 10 minus 12 is a negative number. Negative 10 plus 3 is a negative number. A negative times a negative is a positive. Something between negative 3 and 12 would be like 0. 0 minus 12 is negative. 0 plus 3 is positive. A negative times a positive is negative. Something bigger than 12 would be like 100. 100 minus 12 is positive. 100 plus 3 is positive. And a positive times a positive is positive. So then let's go read our inequality. Oops, let's look at this one right here. Okay, bigger than 0. That is positive numbers. And we are not going to include the zeros on this one. So where is it positive? It is positive in this interval right here, which would be from negative infinity up to negative 3. We just talked about this, but it does not say or equal to, so we are not going to include the negative 3. It is also positive in this section, which would be this interval right here, and that would be your second. Again, a parentheses because we are not including the zeros from 12 up to infinity. Okay, one more example here of kind of our basics. Again, the same thing, I would want to get this equal to 0 before I start solving. So the first thing I'm going to do is add that 16x over. And we have a GCF of 2x. Keep factoring. Factors of 8 that add up to negative 6 would be negative 4 and negative 2. And this time we have 3 things equal to 0. X equals 0, x equals 4, x equals 2. Putting those in the correct order on my number line would go 0, 2, 4. And we'll have to find a sample number in each of those sections. So something less than 0 would be like negative 10, which would be a negative number, times a negative 10 minus 4 is negative. Negative 10 minus 2 is negative. A negative times a negative times a negative would be negative. Something between 0 and 2 would be like 1. And that first spot would be positive. 1 minus 4 is negative. 1 minus 2 is negative. The negative times the negative becomes positive, times the positive is positive. Something between 2 and 4 would be like 3. In that first spot would just be a positive 3 or 6. 3 minus 4 would be negative. 3 minus 2 would be positive. So when I multiply those three types of numbers together, I would get a negative number. Something bigger than 4 would be like 10. 2 times 10 is positive. 10 minus 4 is positive. 10 minus 2 is positive, and we get a positive. And then we have to read our answer. And again, that comes from this part of it. Less than or equal to 0 would be negative numbers. And again, including our zeros. We have two sections that are negative, so that would be our first, negative infinity up to 0, including our 0. And this one right here, from 2 to 4, again, including both of those because of the or equal to. Then we get into some unique solution sets. So looking at this next one, first of all, as I go to find factors of 3 that add up to 2, I run into the fact that there aren't any. There are no factors of 3 that add up to 2. And so then I go to my quadratic formula, which is where I would rely next if I'm finding zeros and it is not factorable. Very quickly, if I were to look at my quadratic formula, negative 2 plus or minus 2 squared minus 4 times 1 times 3 over 2 times 1. I want to look at the part underneath the radical, which would be 4 minus 12. We'd be looking at the square root of negative 8. We are looking at imaginary zeros, which means it doesn't actually hit our x-axis. So if it doesn't hit our x-axis, let's talk about what we're looking at here. We are looking at a parabola, right, an x squared, that is facing up. It's an it's an even positive. And it doesn't hit my x-axis. So it's going to look something like this. The entire graph is above the x-axis. The question then is, where is this graph negative? Okay. Well, to answer that, if we look at this graph will never be below our x-axis. There is no solution. Since we've kind of talked through this one already, let's go ahead and just look at the different possibilities. What if I did that exact same problem, but I changed the question? What if instead of less than 0, we said greater than 0? Okay, well, where is this greater than 0? Everywhere. And everywhere is negative infinity to infinity. So you can kind of see the difference between the two different solutions there, which would be one of our unusual solution sets. We're going to see kind of the same thing happening on this next one. X squared plus 12x plus 36 greater than 0. This one is factorable. It's already equal to 0. Factors of 36 that add up to 12 would be 6 and 6. And you can see that I get the same thing from both, is that we only end up with one number on our sign chart, and that's at x equals negative 6. So as I'm testing out numbers, something less than negative 6 would be like negative 10. And when I put a negative 10 in both of those spots, I get negative times a negative, which is a positive, 0 at negative 6. And then if I have something bigger than negative 6, like 0, I get a positive times a positive, which is also positive. So this one's kind of tricky. And we're going to look at this one in 4 different ways here. So it's asking us, where is this one greater than 0, which would be positive numbers, but not including the zeros. So where is it positive? It is positive here from negative infinity to negative 6, not including negative 6. It is also positive here from negative 6 to infinity, again, not including the negative 6. So that would be our answer if the question was worded as it is above. Let's move that answer over here. So we're going to look at that again. Since I've already done the work, let's look at this one a couple different ways. What if instead I asked you where that one was greater than or equal to 0? And as soon as I get to equal 0, we get to go from negative infinity up to negative 6, including negative 6, and then picking up again at negative 6 and going to infinity. Well, that ends up being all real numbers, and I don't have to break at the negative 6 because we get to include that answer. Let's stick with this one and say, okay, x squared plus 12x plus 36 is less than 0. Where is it negative? Nowhere. There is nowhere on that entire problem that one would be negative. And one last look at this one. This one is a tricky one. Where is this one negative or 0? Because it asks where it is also equal to 0, there is one place that this one does work for that one because it is equal to 0 at negative 6. So at that one location, that problem would be true because it does equal 0 there, and the sign right here says it can equal 0. Okay, and kind of going back to this one, what happened here? Well, we ended up with an x plus 6 twice. So x plus 6 quantity squared. And if you remember what that means it has a 0 at 6 and has a multiplicity of 2. Sorry, a 0 at negative 6 with a multiplicity of 2, which means when we got to negative 6, it bounced off of our x-axis. That's what's happening there, and that's why both of those sides ended up positive on either side of it. And we're going to look at some of those here and kind of speed up our process if we were to have multiplicities in our original problem. So if we look at something like x plus 2 quantity squared times x minus 1 quantity cubed times 3x plus 1 quantity squared less than or equal to 0. Now this one is already equal to 0. It's already factored. So I just need to pull from each of those parentheses what the zeros of this function are, which would be negative 2, positive 1. If I set this one equal to 0 and solve, I would subtract 1 and divide by 3, negative 1/3. So putting those onto my sign chart here, let's see, negative 2, negative 1/3, and positive 1. And again, we just go through and we plug in sample numbers, but we're going to be able to speed this up a little bit here. If I plug in something less than negative 2, like negative 10, now think about this. If I put a negative number in here, negative 10 minus, plus 2 is negative, but when I square it, anything squared always turns out positive. And this first parentheses is squared. Now, so doesn't that mean that every time I plug something into it, it's going to turn out positive, regardless of what that thing is? Same thing happens with our last one. When I plug a negative 10 into 3x plus 1, it's going to be a negative number, but as soon as I square it, it comes out positive. So really, the only one that has an impact on our answer is this one in the middle, because it's cubed, and anything odd will keep the same sign. Anything even will always be positive, which is the same thing that happens with that last one. So as we go through, it doesn't actually matter what number I'm plugging into the first and last one. The first and last will always be positive. It's that middle one that's going to give us our sign. So let's go back to that negative 10 that we were plugging in. Plug in a negative 10 to that middle parentheses. Negative 10 minus 1 is negative 11. Cubed is a negative number. So 2 positives and negative is a negative. Plug in something between negative 2 and negative 1/3, like negative 1. Negative 1 minus 1 is still negative. Cubed is negative, so we get a negative in that section. Something between negative 1/3 and 1 would be like 0. 0 minus 1 is negative. Cubed is negative. And then something bigger, which would give us a negative in that section. Something bigger than 1 would be like 10. Minus 1 is positive. Cubed is positive. And a positive times a positive is a positive. So again, several different ways we could look at this one. It does say less than or equal to 0. So that means negative sections. The or equal to means brackets, but it also means that we get to include zeros. So if I were to have two negative sections next to each other, I don't have to break. And we actually, in this case, have three negative sections together. So this answer set would go from negative infinity, and since these first three intervals are all negative, it goes from negative infinity up to -2, but I don't have to break. So then I just continue on to the next one, which would be -1/3. And I still don't have to break, all the way up to +1, including that +1 would be all of the places that it is negative and 0. And again, if we were to change this to that problem just less than 0, I would have had to break at each of those places. So that answer set would have looked like negative infinity up to -2, break. -2 up to -1/3, break. -1/3 up to 1. So kind of seeing the difference in the two different signs there and how we can write our answers. So let's try one more problem like that on this one. So again, we set up find our zeros first. We would have zeros at 5, -2, and 3/2, 1.5. I have two even parentheses, which again means that everything coming from those parentheses are going to turn out positive. So it's really that one in the middle that's going to impact my answer here. So let's get these in the right order here. -2, 1.5, and 5. And again, from the first and the last, we're getting even exponents, so positive numbers from the first and the last. It's that middle one that we're really going to be plugging numbers into. So something less than -5 would be like -10. -10 plus 2 is negative, so that'd be a negative. Something between -2 and 3/2 would be like 0. 0 plus 2 is positive. Something between 3/2 and 5 would be like 3 plus 2 is positive, and something bigger than 5, like 10 plus 2 is positive. So all of those end up positive, and they want it just greater than 0. So again, that tells me positive numbers, but not including our zeros. So kind of like we looked at on the second part on the last page, is that we're going to have to break at each of those zeros, not including, so parentheses. -2 up to 3/2, break. 3/2 up to 5, break. 5 up to infinity. All right, your assignment then is on page 145, 1 through 5. You're doing 10 through 15. Make sure to skip number 12, and then 51 through 53.